Hello there. In this video I will be showing you how you can get started programming in C. The first thing I would recommend doing is using WSL if you are on Windows. The plain reason is that as I myself am on Linux, I can primarily be recommending things for Linux usage, and Windows is generally worse of a platform to do this on anyways. On any operating system you will be needing GCC and in our case Make. You can install this through any usual means. So on Ubuntu and Debian based systems you will be using sudo apt install gcc and make. The first thing I will get into is a basic project structure. It is highly recommended that you have one folder in which you contain one project. So if you are making a game, then you have a dedicated folder for this game. This goes for all programs. In this folder, the way I like to do things is I have the Makefile at the top level of the directory, then I have a directory called src and a directory called out, and then in the src directory I have my main.c. So this is how my typical project directory looks like. As I've mentioned earlier, we will be using Make, which is the build system. You're welcome to use any other build systems such as Ninja or CMake. However, I very much prefer just using Make as it is completely sufficient for me, and going beyond this would only make projects unnecessarily complicated. The reason we are using Make at all is so that once we have a larger amount of files, we do not constantly need to be using a longer and longer compile command, but rather so that we can have smarter rules based in our Makefile. To actually define these rules, we will however need to edit this Makefile. You can do this with whichever editor of your choice. On Windows you have of course the option between any of your standard IDEs or Notepad++ if you wish. On Linux most of these options are also available, and what I preferred using, Vim. So in whichever editor you have chosen to use, we shall open up the Makefile, and as I like to do things, I first start off with an environment variable to specify the compiler, which I'm going to set to GCC. So we just write out cc equals GCC. The two C's at the start are capitalized to keep in with standards of naming conventions. In case you later on need this, you can also have a flags variable. However, currently I will not set this with anything. I will drop two lines to separate this and have a all rule, which is followed by a colon and a space, as the all rule is automatically triggered when just using the make command without specifying any specific rule. After the colon space, we are going to add whatever the name of our program is supposed to be, so I'm just going to say program. It is entirely up to you what you name here. However, then I'm going to drop two more lines, and then whatever I put behind the colon space, so in my case program, I'm going to just repeat this and add a colon and then drop a line. What this does is that whatever I have now on this line after the two spaces will be what executes from the rule if someone attempts to use make program. However, as all is the default rule, if someone only specifies make, this is interpreted as make all, which is interpreted as make program. So in here, I'm going to be referencing our compiler, so the environment variable cc. We do this by using a $sign, and then followed by this in brackets, we're going to put the name of the environment variable, so cc, space, and then we want to include the project files. So currently we only have src/main.c. We're going to use a space to separate this, and then we want to use the -o flag followed by another space, and here we specify what the compiled binary should look like. As we have created a directory for out, we will just say out/ and then program. The final rule that we need for the moment is a cleaning rule. So for this, I'm going to drop two more lines, and I'm going to say clean colon and drop a line. And this is just an easy rm-rf out/snowflake. Of course, from what I understand, if you're using this in WSL, this should also work just fine. What this clean rule does is that if someone uses make space clean to specify this rule, then this just clears out everything within the out directory. Due to this, it is also important that you do not store any important files within this out directory, as it is only intended for compiler outputs. I am just going to quickly add a hello world example to the main.c so that we can see the build system working. For this, we are going to #include, and then I like to use angle brackets for system imports, stdio.h. We will drop two lines to separate the includes from the rest. Here we're going to make an integer of main brackets curly brackets. We are going to print f brackets quotation marks hello world, and then we add a backward slash and an n. This /n is important if you do not want your program to be slightly odd, as /n means new line, so that if this is printed out, this prints out a new line. This also means that you can print 2 of these, and it's going to have 2 new lines. At the end of this line behind the brackets, we're going to add a semicolon, and we're going to drop 2 more lines and return a 0, which indicates that the program was successful. We will return back to a normal terminal program where we have navigated to this directory with our makefile out and src, and we're going to run make. As I've explained earlier, make automatically defaults to make all, which just uses the program rule, which means that it should compile our program. And as we see, this message looks very promising as it has not put out any error messages. We can ls the out directory and see our program. To try running it, we can in the terminal go ./out/program, enter, and as we can see, it prints hello world. At this point, you are welcome to try to apply some of the rules of programming you might already know. Once you have modified the program to your liking, you can just go make and ./out/program again, and these changes should apply. Sometimes it may be necessary that you use make clean before you remake your project for it to properly clear out all output files. However, this should only become an issue once you have bigger projects. The last thing I will cover is the usage of multiple files. If you have a bigger project than just a simple hello world, you will end up having a significantly larger main.c file. Now, while some programming ideologies prefer this style of programming, calling it subtlest, for various factors this may not be a good thing, and just generally some people may not like it and would rather structure the project in different files. This is very much doable. To do this, of course, you will want to, in your src directory, add the other file, which should also have the .c ending. It is very helpful if you have a descriptive name, and you will also need to have the same file but with the .h ending instead of the c ending. This is very important. In your utils.c file, you can continue writing whatever you wish, so I'm just going to have a very simple function, which all it does is run hello world. So once again, include stdio.h, define a void, print hello, brackets, printf, hello world, exclamation point, /n, semicolon. And then to call this printhello function from our main.c file, we will need to also edit the utils.h. The utils.h is the so-called header file. The header file is intended to just be a definition of everything the utils.c file is exposing to other files. So if I had another function in here, which was only to be used by the printhello function, but not by, say, the main.c file, then I could only expose the printhello function through utils.h. To do this simply, we can copy the function definition line from utils.c and remove the opening curly brace and just add a semicolon. So we here just say that it's a void and the function. Something to keep in mind here is that if, say, you do not have a void function, but say a struct, you will also in the header file need to include whichever file provides this struct. Now finally, to use this printhello function in our main.c file, we will here below the include stdio, I will be adding 2 lines as I like to separate my system imports from my local file imports. But once again, I will say #include space, and then instead of using the angled brackets, I will be using the quotation marks and be saying utils.h. Notice that I am not importing the .c file, but the .h file. Now to use this function, I will just here say print hello, brackets, semicolon. However, this will not quite work yet, as the utils.c file is not getting compiled yet. So we also need to edit the makefile. For this, we will need to edit the program rule, and just need to, behind src/main.c, add src/util.c. We do not need to add the header file here. After this, we can quit out. I will make clean and make. And as we can see, the outputted command is correctly updated. Now let's go ./out/program. And as we can see, it calls the function correctly. The final thing to add to using multiple files is how you can recompile to multiple objects. The way this would be done is here you can add another rule before the program rule, say in our case utils.o. As the contents of the rule, we will use cc, specify the file to compile, utils.c, and then with our -o flag, specify out/utils.o. The way we need to also adapt this, however, is that we also need an object file for our main. So we will also add a rule main.o and use then the cc src /main.c-o out /main.o. Now, what we will change about the program rule is we remove the entire line about compiling stuff, and just after the colon add a space, and then say utils.o and main.o. Now, all we need to do is add a -c behind the $(cc) for both the object rules, so that it knows to compile these as an object, and actually for the program rule, we also need to compile it with cc, but without a -c, and we give it both of these .o's, which refers to the utils.o and the main.o object file, and we just specify then -o out /program. And actually, these here need to be out /main.o and out /utils.o. What this means is that when it tries to run the program rule, it first does both the utils.o and the main.o rules so that those objects are compiled, and with the compiler of GCC, it turns both of those object files into our final program. Now if we exit and go make, this puts out the 3 correct commands. So first it compiles main.c, utils.c, and then it links both of them towards out /program. So now we can also use the treat command in my case, and we can see that we have these 3 compiled things in our out folder. Speaking of which, let's go ./out /program, and it still correctly functions, but using these 2 compiled files. And with that, I would like to thank you for watching. If this video was helpful, it would be greatly appreciated if you could leave a comment and like the video. Currently, on the left of the screen, there is a playlist of all of my tutorials on how to code in C, whilst on the right there should be a tutorial on the general basics of programming, which is applicable to all languages. Thank you.